This is the second part of my video about derivatives of inverse functions. I want to focus on derivatives of inverse trig functions in this part of the video. So let's start by taking a look at an example. Let's let f of x equals sine of x. And we're going to restrict our x values to be from negative pi over 2 to pi over 2 so that we can define an inverse. And so g of x will be the inverse of that function. Let's see if we can find g prime of a half. So first of all, we actually have a name for the inverse of this function. The inverse of sine of x is our arcsine, or our inverse sine. We'll say more about that later, but for now, let's just use the same method we used in the previous video. So the inverse of y equals sine of x is x equals sine of y. I'm going to take my derivative implicitly. Derivative of x is 1. Derivative of sine of y is cosine of y, and then I have to multiply by y prime. That's the chain rule. Solve for y prime. I get 1 divided by cosine y. So the derivative of the inverse of sine x is the reciprocal of the derivative of sine x. Now let's see if we can evaluate this derivative for the inverse when x is a half. So if x is a half, I'm going to plug that into my inverse. So I get 1/2 equals sine of y. And I need to figure out what angle has a sine of a half. Now, this is where it's going to be important to recognize that we did restrict ourselves to angles between negative pi over 2 and pi over 2. So we're in quadrant 1 or quadrant 4. Sine is the y coordinate on the unit circle, so that tells me since it's positive, I'm in quadrant 1. And sine is equal to a half when you have an angle of 30 degrees or pi over 6. So my angle, my y, is pi over 6. Plugging that into my derivative, I get 1 divided by cosine of pi over 6, or 1 divided by root 3 over 2, or 2 divided by root 3. And that's the derivative of the inverse sine, basically. That's my derivative of the inverse of sine of x. Now, inverse trig functions come up a lot, and so rather than working on finding a derivative at a specific x value, or specific input, let's see if we can use this process to come up with the derivative of arcsine of x, which is my inverse of sine, and let's just see if we can find the derivative of that function in general. So I've got the function y equals arcsine of x. This is the inverse of sine, so this function is equivalent to x equals sine of y. That should look familiar. That's how we started the previous problem. The inverse of sine is x equals sine of y. We can take the derivative implicitly. We actually already did that, so I'll just copy down my work. When we did that earlier, we got y prime is 1 divided by cosine of y. Now the next thing I want to do is I really want to get this derivative in terms of x. I want to be able to just work in terms of x. I don't want it to be in terms of y. And so I'm going to draw a right triangle to help me do this. We started with the equation x equals sine of y. That's the function we're working with. So if sine of y is x, or x over 1, I'm going to draw a right triangle. My angle is y. Sine is opposite over hypotenuse. So I'm going to label the opposite with x and the hypotenuse with 1. I can then use my Pythagorean formula to find the missing side of that triangle. I know that a squared plus x squared has to equal 1 squared. And so if I solve for a, I get that missing side, that adjacent side, has to be the square root of 1 minus x squared. So using my right triangle then, cosine of angle y is adjacent over hypotenuse. So cosine of y has to be square root of 1 minus x squared divided by 1, or just square root of 1 minus x squared. Plugging that into my derivative, I get y prime equals 1 divided by the square root of 1 minus x squared. And that is the derivative of our arcsine function. We can find derivatives of our other inverse trig functions using the exact same method. I have them all written on the screen here. So derivative of inverse sine, which is also called arcsine, we just derived that one. we got 1 divided by square root of 1 minus x squared. Derivative of our arc cosine is actually almost identical. It just has a negative. It's negative 1 divided by 1 minus x squared. Derivative of arc secant is 1 over x times the square root of x squared minus 1. And our arc cosecant looks the same except it's negative. Derivative of arc tangent is 1 over 1 plus x squared. And derivative of arc cotangent looks the same, but it's negative. So now we've got some new derivatives to learn. These are derivatives of our inverse trig functions. So we can use these new derivatives now in combination with our product rule, quotient rule, and chain rule, with the other ideas that we've learned in this class. So let's see if we can find the derivative of f of x equals x arc sine of x. This is a product. The x in front is being multiplied by arc sine of x. So I'm going to have to use the product rule. I'll let my f equal x, and g is arc sine of x. Then f prime, the derivative of x, is 1, and the derivative of arc sine, well, we just learned that that's 1 divided by square root of 1 minus x squared. So putting this into my product rule, I have to take f prime times g plus g prime times f. So I got 1 times arc sine of x plus x times 1 over square root of x minus, it's 1 over square root of 1 minus x squared. I would probably just rewrite that as arc sine of x plus x divided by square root 1 minus x squared. All right, let's look at one more. Let's find the derivative of arctan of 4 divided by x. This is now a chain rule problem. The 4 divided by x is inside the arctan. It's not being multiplied. It's inside that function. So my outside function is my arctan. And the derivative of arctan was 1 over 1 plus x squared. So that means my outside derivative for arctan of 4 over x is going to be 1 over 1 plus 4 over x squared. That's my outside derivative. And then if I'm using the chain rule, I have to multiply by the derivative of the inside. The inside function is 4 over x, which we can rewrite as 4 x to the negative 1. The derivative of that, bring down the negative 1, would be negative 4 x to the negative 2. I can rewrite that as negative 4 over x squared. So I have to multiply by my inside derivative, which is negative 4 over x squared. Finally, I'm going to simplify this answer. So we've got 1 over 1 plus, if we square the 4 over x, we get 16 over x squared. And then I'm going to multiply that by negative 4 over x squared. So negative 4 times 1 is negative 4. And then in the denominator, x squared times 1 is x squared. X squared times 16 over x squared. Those x squareds cancel out, and we're just left with 16. And there's my final answer. My derivative is negative 4 over x squared plus 16. All right, that was my last example. Let me know if you have any questions.